All right, we're getting into inequalities. So the first thing to talk about is the graphs of inequalities, just to remind you of this. So say we have some number is less than or equal to 0. So m, any number less than or equal to 0, what are the solutions for m? So if m is equal to this number, then you're going to have a number line with these numbers, right, in order, making sure that your numbers go in order from left to right. Always putting whatever number is placed here in the middle. So 0 is in the middle. So I have -2, -1, 0, 1, 2 as my tick marks. And I have it's equal to 0, so I'm closing that circle, showing my equality there. And then what are my values that are less than or equal to 0? Well, equal is closed, and less than is all of these values less than 0, like -1, -2, and so on. But even in between all of those, that's why this is closed, because it really is just showing all my solutions. Now, just to remind you, you can use any letter. So I picked M. I also picked A, and I wrote it backwards. This means the same thing. This actually represents the graph as well. You have 0 is greater or equal to the A, right? So that means that 0 is the greatest number and also equal to all the other ones, the possibility of that. So pretty much, if you see how it flips, and if you're comfortable with it, I'm more comfortable with the variable going first, that's fine. But just notice how not only does the variable flip, but so does that inequality symbol and then the number. Okay, sometimes you got to read it backwards. I want you to be comfortable with that. All right, the next example I have for you here is k is greater than -5. So again, a number line in order. I see this all the time with negatives, that you put the number line backwards. Now, because they're negative, it's like going backwards. The larger the negative number is, the smaller it is. So -3, -4, -5, -6, -7 goes that way instead of make sure that that is correct. Picture your 0 and realize you're always building that number, -3, -4, and so on. Anyway, so then after that, I always put the number that's here, my -5, in the middle, and then all the values that are k that are more than -5, are they equal to -5? No. So the open circle represents that it's actually not equal to that number, but the first number it's equal to is this shaded region, which is like -4.99999999999. That is true. That is greater than -5, and so on and so forth, going that way and that way. Again, if you're going to have it flipped where your variable comes second, notice how the inequality is flipped. So -5 is less than g is equivalent to this. So remind yourself of that when you do need to flip it. Say you get an answer like this, but you're not sure, make sure you flip that around. All right, the next thing that we kind of expect you to know at this point is writing an inequality. And to write an inequality, if you see here, you have a number line. It's shaded at 2, and all the values are greater than 2, right? 3, 4 is greater than 2. So you pick your favorite variable. I'll use n. And n is greater or equal, because it's closed, to that number 2. And that's all there is to that. The next thing we're getting into is solving one-step inequalities. So we've already done one-step equations, and I picked a very simple one here. I have x plus 5 equals 10. And to get x alone, I subtract 5, and I have x equals 5. You don't have to write that down, just look at it. Does that make sense to you? Do you remember doing this? You're undoing what's happening there. If this were a minus, I wouldn't subtract, instead I would add, and I would get 15. Okay, so pretty much one-step inequalities, all you got to do, right, with adding and subtracting, all you got to do is undo what's happening. So it's the same exact thing. 5x plus 5, get this one down, is less than 10 instead of equal. Then I'm still solving for x the same way. Subtract 5 from both sides, and then I get x, but instead of equal is less than 5. In order to graph that, I have all my values are not equal to just 5. They're not even equal to 5, but less than 5. So there's a lot of solutions to that. So we want to graph it to show all those solutions. So I have an open circle at 5, and then I shade to the left where all my values are less than 5. All right, the next 3 I want you to try on your own. pause the video. You're expected to solve the inequality and then graph your solution. Hit play when you're done. All right, for this first one, I need to add 9. Let me use a different color. I'm going to add 9, and I get x is less than or equal to 12. So I place my 12 in the middle and add my numbers around it. It's equal to it, so it's a closed circle. It's less than it, so I go to the left. All right, number 2, it's subtracting 9.9 from p, so I'm going to add 9.2. And I get p is less than, okay, these are different signs, so I subtract. -5 plus 9.2 is 4.2. And there's a couple of different ways you can create your number line when there's not integers. I still like to have my integers there, so I know that I'm between 4 and 5, and then I'll just add my other numbers. And I'm 0.2 away from 4, so I'm pretty close to it, probably about here. It's an open circle because there's no equal sign, and a less than are all the values to the left. Okay, last one here, I have this flipped. I know some students like to rearrange it, so I'm going to do that. I have m is -1/2, so that order stays. This symbol, this inequality, is flipped to less than or equal to 1. Oh, you can't see that, I'm so sorry. So I rewrote it. M -1/2 is less than or equal to 1. So now I add 1/2 to both sides. Add 1/2, and I get 1 plus 1/2, and m is then less than or equal to 1 plus 1/2, which is 1 and 1/2. So again, I'm going to stick with integers to make my number line. Here's 1, here's 2, here's 3, 0, -1. 1.5 is directly in the middle. It's equal, so it's a closed circle. Oh my goodness, all of these were less than. And then it goes to the left. I should have made one of them greater. Oh well. All right, last thing to talk about. Get this down, pause it whenever you need to. Sometimes we have to write verbal sentences and turn them into inequalities and then solve those inequalities. So we have here, you're checking a bag at the airport. This is real life. Going on vacation. How nice. Bags can weigh no more than 40 pounds. So far, your bag weighs 16.8 pounds. Find the possible weights and pounds that you can add to the bag. So yes, I'm sure you can think about it and get this answer, but I want you to write and solve an inequality just like the directions say. So my variable, my unknown, is W, and the bag can weigh no more than. No more than is the biggest thing. No more than. So 40 is the total amount, but it can equal 40. And then I have extra weight, my W, that I can add, and I already have 16.8. So that's writing my inequality. That's the hard part. Now I know to just subtract 16.8 from both sides, which gives me 23.2. W is less than or equal to 23.2, excuse me. So what that means is that you can add no more than 23.2 pounds into your bag. So 23.3, no good. 23.2, fine. Anything less than that, 23, 22, 21, just fine. Awesome.